Welcome back to Tech 240 for Wednesday, January 13th. In this video, I'm going to set you up to successfully complete most of the labs in the first third of the semester. And I'm going to do that by giving you an orientation to the TinkerCAD online software tool. We're going to use TinkerCAD quite a bit in the first third of this class. We're going to use it for Lab 1, Lab 2, not for Lab 3, but then we'll come back to it for Lab 4, 5, 6, and 7. So if you look in your course schedule, that's almost all of the labs in the first third of this class. So we're going to use it quite a lot, and you'll get very good at it as a result. But don't worry, it's really a very friendly software tool. It's intuitive, it's easy to use, and it's very easy to learn as well. All you really need to do is watch this demonstration and then spend 20-25 minutes, something like that, playing around with it, and you'll have a pretty good grasp of it. I know that some of you may have used TinkerCAD already in the past for different courses or applications, and that's great. You should still watch this video just to get a refresher, and also because there might be certain things that I want you to do a little bit differently than you've done it in the past. For example, what it is that I want you to take a screen capture of, so that you can submit that screen capture when you go and submit the lab in ReggieNet. You know, when I think back to summer of 2020, when I first realized I was going to be teaching this class online, at least for the fall semester, I knew I was going to need some type of online circuit simulation tool. So I tried out probably 10 different ones, and there's no doubt that TinkerCAD is one of the best ones out there. Even though TinkerCAD is really simple and easy to use, or maybe because it's so simple and easy to use, it can also be a little bit limiting. If you ask it to do too much, like what we're going to do in the last third of the semester, those types of labs, if you ask TinkerCAD to do that, it runs into problems. It gets really slow and glitchy, and sometimes it just won't run. It won't work. So for that reason, we're only going to use TinkerCAD for the first third of the semester. And then for the second third of the semester, we actually don't need any software for that. And then for the last third of the semester, we're going to use a different tool. It's also a very good tool. It's a little bit more heavily used by industry, and it's called Multi-Sim Live. And it's also a pretty intuitive program that we'll talk about more when we get to it in the last third of the semester. But for now, TinkerCAD is more than capable of doing all the labs that we're going to do in the first third of the semester. So that's what we're going to use for right now. So let's get into it, and I'm going to go ahead and share my screen. Okay, so we are going to create a new tab and just go to tinkercad.com. And I intentionally logged out because this is probably the screen that you're going to see if you don't have an account, which I'm assuming you don't. So you're going to need to create an account. It's free. All you need is an email address. So if you want to create a garbage email address, that's fine. I used my real Ilstu email account. And so I'm going to go ahead and sign in. But if you don't have an account already, you'll need to create an account. When you get to this screen, you do not need to click on join your class because I haven't set anything officially up in tinkercad.com. So just go ahead and log in like normal. So it's going to ask me to log in, and I'm entering my email address and enter my password. I hope I remember it. Okay, and I'm in. All right, so TinkerCAD does a lot of different stuff. It's obviously CAD software, but the circuits part is just kind of an extra thing that it has. So over here on the left, you want to click on Circuits, and then click Create a New Circuit. So this opens up a new file. All right, so this is a brand new file. And the first thing I want you to do is change the file name. All right, so up here, I think it just automatically populates some kind of funny, humorous name. So go ahead, and this is one thing I want you to do, that if you, even if you've used TinkerCAD, you wouldn't know this. So when you change your file name, here's what I want you to do. I want you to type in your last name and then lab X, whatever number we're working on. So this, let's just call this lab 1, even though I'm not going to do lab 1 for you right here. I'm going to call it lab 1. So you'll type in your last name and then lab 1. And then it will save it. It's one of these, it's an online program, so it'll automatically save it all the time. You don't have to click save or anything. When you log back in, you can click on this and it'll be just like you left it. All right, so all of your components are over here on the right-hand side, and I'm going to go ahead and select all the components, not just the basic components. So the drop down here says basic or all. I'm going to click on all. So this gives me all the different components that TinkerCAD has to work with. So the most basic components are up here towards the top. We're going to be working obviously with resistors in pretty much almost all of the labs that we do. We're not going to work in the first third of the semester with capacitors or inductors. We might get into diodes later. We will be using push buttons and slide switches. A potentiometer is just a variable resistor. We probably won't have a need for that. Photoresistor, the resistance depends on the light input. We probably won't use that. Let me scroll down and see what other things we're going to use. LEDs, that's lab 5. We're going to talk a lot more about LEDs in lab 5. Light bulbs, we'll probably use that later just as kind of a general output. Scrolling down, there's a bunch of motors. We're going to talk about motors in the second third of the semester, but probably not going to use TinkerCAD. Here's a bunch of power sources. I think it's kind of amusing that they have a potato battery. You can power your circuit with a potato battery or a lemon battery. And you've probably seen this in science class before, how you can put a nail, and basically it's a chemical reaction, a redox reaction that causes a difference in potential, and you can actually create a voltage source. We're not going to talk a lot about potato batteries or lemon batteries, but there's different kinds of batteries. If you want, you can power your circuit with a 9-volt battery or a AA or AAA or D cell, C cell. They're all 1.5 volts about. Coin cell battery, like what I've got in my guitar tuner over there, or banjo tuner. A couple different breadboards, we're going to use those. Coming down here. Instruments, we're going to use the power supply. That's what I'm going to use mostly. Instead of those 9-volt batteries and AA batteries, we're just going to use the power supply. And the multimeter, we're going to use that a lot. The multimeter is what you use to measure resistance and voltage and current. So it's kind of like the online version of this. The integrated circuits, the chips down here, we're not going to get into this too much. Oh, we are going to use these relays down here. So this relay is, it says SPDT, that stands for single pole double throw. We'll talk more about that in a couple of class periods. This is a DPDT relay, that means double pole double throw. We are going to use these in a few labs later on. And here's some more chips down here. We are going to talk a little bit about these. These are our logic gates. So we are going to talk about NAND, NOR, and OR. We'll talk more about those. We may or may not use these actual chips. There are different ways to do it. You don't have to use these chips. So we may end up using those, and I think that's it. Yeah, so that's pretty much it. There's a handful of components that we're going to use in this class. So it's pretty straightforward. So let's just do a real simple demonstration like you're going to have to do for lab 1. So I'm going to start out with a breadboard. Let me go find a breadboard. Did I pass it? No, it's down here. Okay. So let's just get a small breadboard. So I click on that, and then I can drag and drop it anywhere. You can drag and drop it, or you can just click, either one. And then if I scroll on my scroll wheel, I can make it bigger or smaller, and I can pan, I can move it around however I want. All right, that looks pretty good. A reminder of how breadboards are wired. I always have to do this because if I don't, there's always questions, and that's okay. You're probably not real used to working with breadboards. So up here, this is a power rail, and all of these dots are connected. This is how a real breadboard works too. All of these are connected with a strip of metal underneath the surface of the breadboard. Similarly, down here, all of these are connected with a strip of metal. All right, so this is directly connected to every other hole on this breadboard. That's the way it works for the top and the bottom of the breadboard down here. They're connected horizontally, the way we've got it oriented like this. They're connected horizontally. Right? In the middle here, it's the opposite. So here, pick one right here. So let's say that pin right there is connected with a little thin metal strip underneath the surface of the breadboard to that pin and all the other pins in this vertical row like this. All right. So if let's go ahead and insert a resistor. Here's a resistor. So I'm just going to drag it out here. So if I take this resistor and if I were to put it like that, now this resistor, one wire leg of the resistor is going in this hole of the breadboard, and the other leg of the resistor is going in this hole in the breadboard, and it's actually shorted out. This is not what you want to do, because that resistor is actually shorted out by that strip of metal underneath the breadboard. So that is not going to work. If you try to measure the resistance of this, it's going to be 0. It's not going to work because it's shorted out. So what you have to do is rotate it. So no problem. Make sure you have the item selected that you want to rotate. And then up here in the upper left, there's the rotate button. So now I can rotate this. And I want to make it like that to make my resistor so it's connected between this row and this row right here. So now I could measure the resistance between any hole in this vertical column and any hole in this vertical column, and that would give me the resistance of this resistor. And I'm going to drag, oops, no, I didn't want to do that. Okay, well, that's fine. That's how I make a wire, and I can move the wire around just by clicking on any hole, and I can click and I can make the wire in any shape I want to. And then I didn't really want that wire there, so I can either click on the trash button or I can just press delete and get rid of it. All right. So what I was starting to say was all of these holes in this vertical column are connected, and all of the holes in this vertical column are connected. And, oh, I was starting to say how you can change the value of the resistor. So I can click on the resistor, and right now by default it's set to 1 kiloohm. Be careful of this unit. I can change what unit it's at. So just for fun, let's say that it's 100 ohms. That resistor is 100 ohms. And you can notice when you change the value, it automatically changes the color bands to be correct. So now I've got a 100 ohm resistor. Let's do, you can actually copy and paste another resistor, but let's just drag another one in and another one as well. I'll copy and paste this one. So I'm going to Control C to copy that one, and then I'll paste another one right there. And I don't know, let's say this one, let's leave that one 1 kiloohm, and let's say this one is 10 kiloohms, just for fun. So this one is 100 ohms, this one is 1 kiloohm, and this one is 10 kiloohms. Be really careful. I'm sure that some people are going to get the units mixed up. So be real careful about what units your resistors are set to. Okay, I want this to be 10 kiloohms. All right. Now I want to put these resistors in, I'll start out by putting them in parallel with our original resistor. So I'm going to rotate it and then drag it down here like that. Same thing with this one. Let's rotate it and then drag it down. All right. Okay, so now they are all in parallel because the legs of each of them are connected on each side. Remember, this whole vertical row, they're all connected by a wire strip underneath here. So these are all connected on one side, and on the other side, these are all connected right here. So I've got 3 resistors that are all in parallel. And part of lab 1 is measuring resistance in series and parallel. So let's go ahead and measure this resistance. So I scroll down here on the right to find a multimeter. Toward the bottom, I know. There it is. There's a multimeter, and I'll put it right here. Looks good. I'm going to zoom in a little bit. Okay. And this one multimeter, just like a real multimeter, with a real multimeter, I can switch between measuring resistances down here. In one, if I have it set down here, I can measure resistance. If I have it set up here, one of these settings, I can measure DC voltage. And over here, I can measure current. So this one device can measure voltage and current and resistance. Same thing with this multimeter in TinkerCAD. You just have to set it to a different mode. So right now, by default, this multimeter is set to measure voltage. You can see because it's darkened in right there. Lab 1 is just about resistance. So I'm going to set it to resistance. So now it'll measure resistance. And to get a wire, I'm going to take and click on one of the probes for the meter. And the easiest way to do this is just click on this and then click wherever you want it to go. I want it to go to that pin right there. And then you can make it look pretty. You can make the wire look pretty. So I'm going to click on the wire, and now I can move it anywhere around. So I'm going to go vertically down like that, and then I'll double click here. And you can see it snaps to horizontal and vertical. So I want it to be like that. There, that looks pretty. And you can also change the color of the wire. I'll make this one black. And I'm going to do the same thing for this side. So this is going to be connected to this pin right here. Now I'll make it look pretty. I'll make this part go straight down, and then this will go, yeah. There, that looks a little bit prettier. So I'm going to make this side red. All right, so now we're all set. We are all set to measure resistance. It's not doing it yet, though. It's not measuring resistance. It won't run the simulation until you click the Start button up here. So as soon as I click Start, all right, so it starts. All right, so we find that the resistance of these 3 resistors in parallel is 90.1 ohms. So the resistance of a 100 ohm, a 1 kilo ohm, and a 10 kilo ohm resistor is about 90 ohms, which makes sense. If you've done a few of these calculations, you'll start to get an intuition for what this ought to be. And that makes sense. That's fairly intuitive. All right, I'm going to click Stop Simulation. And I'll go ahead and we'll do them in series now, because Lab 1 is all about measuring resistances in series and parallel. So to do that, I'm going to rearrange some stuff. I'm going to delete this wire, delete this wire. And what should we do? Let's put all 3 of these in series. Okay, so I'll put this resistor right there. I'm going to put this resistor. I'm dragging and dropping. To put it in series, I got to put the right leg of this resistor in the same vertical column as the left leg of that first resistor, the one I just moved. Okay, so I need to put it like right there. Or right there, either one would work, or right there, or right there. But you get the idea. Right there is going to work. And then this one, I want to put that in series also. So to make this work, oh, you know what? I'm going to leave it right there. I'm going to show you a different way of doing it. So I could move this resistor over there, and then all 3 would be in series, or I could use a wire. So I'm going to do that just to be a little bit different. So I'm going to put a wire between here and right there. So now I'm going to change that one to turquoise. Yeah, okay, it's crazy. All right, so now I've got these 3 resistors in series, and now I'm going to measure the resistance of these 3 in series. So same thing again, we'll take a wire and go down to here. Now we'll make it pretty. Wherever possible, it's a good idea to use as many straight lines, and not only straight, but vertical and horizontal lines as you can in schematics. Otherwise, it turns into a bird's nest. All right, so use as many vertical and horizontal lines as you can, especially as these things get more complicated. It makes things easier to see if you use vertical and horizontal lines. It also makes it easier if you use different colors. In general, positive side of a circuit is red, negative side of a circuit is black. And in between, you know, if something is not exactly the positive side or the negative side, you can do whatever you want. You can use whatever color you want. That's why I use turquoise right here. All right, so we're all set. This should work. I should be able to measure the resistance of these resistors in series. This is still set to resistance, so we're all good to go. Let's press start. There we go. All right, so notice this auto scales to the units. All right, so before, when they were in parallel, it measured 90-ish ohms. Now it's in kilo ohms. All right, so once again, this makes sense. If you've done a few of these, this should make sense. We've got a 10 kilo ohm, a 1 kilo ohm, and a 100 ohm, not necessarily in that order, resistors, and they're in series. So when I combine them, it gives us 11.1 kilo ohms. Okay, hopefully that's pretty straightforward. That's actually it for lab 1. You're going to do this with different resistors in different configurations in series and parallel. But that's basically it for lab 1. Let me go ahead and keep going because you're going to have to do a little bit more in lab 2. Lab 2, you're going to actually apply a power supply and cause current to flow, and you'll measure voltage drops and current flow and such. So while I'm here, let me go ahead and if you want to stop now, that's fine. You've got enough information to do lab 1 with just this. Oh, let me say one more thing before I move on. After you're done with the lab, I want you to take the last thing that you did in this lab and take a screenshot of it. Make sure in the screenshot you get your file name. So I would take a screenshot of the whole window, or you can just select part of it, but make sure you get your file name so I can see your last name, lab number, and make sure you get the whole circuit that you designed. Take a screenshot of that, save it as a JPEG, or you can put it into a PDF, or even a Word doc if you want to. That's fine. And I want you to upload that in addition to your lab. Okay? I want to see your circuit that you designed so I can help you if necessary. Okay? So I'm going to want you to do that for labs 1, 2, 4, 5, 6, and 7. After you're done with the last circuit that you design in that lab, take a screenshot, save it, upload that along with your lab. Okay. All right, now I'm going to go on to talking about lab 2. Just a couple more things that we're going to add in lab 2. And we are going to add a power supply. So that's this right here. So let's add this. And with your power supply, you can name the power supply. You can set the voltage, just like on a real power supply. For most of our labs, we're going to do 20 volts. We'll change that sometimes, but 20 volts is a default. Current, you don't usually have to change. This refers to the maximum current that this will put out. So if you leave it at 5 amps, it's in amps. That should be fine for our purposes. Okay, so now, let's see. Oh, I want to show you something right now. I'm going to do something that's not going to work, okay? So first of all, let me connect my power supply, and I'm going to do this in the way that is probably the best practice. So I'm going to connect the positive side over here to the positive rail. Then I'll make it pretty. Like that. And I want that to be red. Ooh, red. There. And then I'll connect another wire to the negative side of the power rail on the breadboard. And I want that one to be black. All right, so now this whole strip on the breadboard will be, when I turn it on, it'll be at 20 volts. And this whole strip, horizontal strip of the breadboard, will be at 0 or ground, essentially. So now I'm going to connect these resistors. I know they're in series. I'm going to connect them to the power rail. So let's say this is that, well, it doesn't matter. Let's say this is the positive side, actually. So I'm going to connect this wire to here, and then I'll connect on the other side this wire to here. All right, so I have just made a complete circuit. So in case that's not clear how that worked, if you follow an electron, say, as it goes from the power supply, it'll come, ooh, I need to be careful here, because remember, electrons go from negative to positive. So let's not say that. Let's say that we're following the path of current, of conventional current, all right? So the path of conventional current goes from the positive side through the red wire to this strip, and then it's going to go through this wire to this strip of the breadboard, and then it's going to go through this resistor, and then through this resistor, and then through this wire, and then through this resistor, and then it's going to go through this wire, and then to the negative side of the power supply. And that is our complete circuit, right? So we got a complete circuit. And let's say I want to measure the resistance of these resistors simultaneously. All right, so let's make sure everything is all set. Yep, so now I'm going to click Start and see what happens. Oh, something bad happened. All right, I did this on purpose. I really did, believe me. And the reason I wanted to show you this is because you might do this accidentally. This is true in real life too. You can't measure the resistance of a circuit while it's energized. Why? Because what you're doing in this path, in this circuit, you've created an alternate path for current. And that path is for current to flow through the measurement device. And if you're trying to measure resistance, you don't want that. You're trying to measure the resistance of these resistors. And you're not, the problem is that current is simultaneously flowing through the multimeter. And it's the exact same thing in real life. So this is actually realistic. So if you want to measure resistance, you cannot have the circuit energized. You can't have current flowing through the circuit while measuring resistance. So let's see, will it let me delete this while it's running? No. Okay, it stopped the simulation when I did that. So now I got to click Start again. And now it'll measure resistance, but I don't have a complete circuit. All right, so the point is, you might do this, and I might get questions about this if I didn't point this out. So you can't measure resistance in a circuit while current is flowing through that circuit. Okay, that's what I wanted to point out. Okay, so I'm going to stop the simulation. Let's say in lab 2, we want to measure voltage drops and current flow through the circuit. All right, so let's go ahead and do that. So I'm going to delete these. I'm going to have to change some things about the circuit. Let's connect this down to here. And what do we want to measure? Let's measure the voltage drop across the middle resistor, and simultaneously let's measure the current flow through the circuit. All right, they're in series. We'll talk about this later, but they're in series, so the current is going to be the same through the entire circuit. All right, if that doesn't make sense to you right now, that's fine. We'll talk more about it later. So I want another meter that's going to measure current flow through this circuit. So first of all, let's set this up to measure voltage drop across this middle resistor. Why? Because, I don't know, that's what we want to do right now. So let's measure the voltage drop. I'm going to set this up so that I'm going to get something funky so I can tell you something else. All right, so let's do this one, connect this to here, and let's connect, okay, let's make it pretty. And I'm going to connect this one to here. All right, so I've connected my multimeter, so it's measuring across. Remember, voltage is an across variable. So I'm measuring the voltage across this second resistor, right? Because this vertical column is all connected, and this vertical column is, oh, that's wrong. That's in the wrong spot. If you get something you're not expecting, double check. I'm glad I did that. That way it's a learning opportunity. Make sure you check your position of your wires, because you got to be careful which hole you put it in. All right, that's fine. All right, so I should be able to measure the voltage drop across this second resistor now. And also, well, let's just do that first. Let's run it like that. All right, and then we'll talk about current. All right, so it looks like, do I have everything all set? Tracing the path of the current flow. Yeah, this should work. All right, and when I do this, I should get the voltage drop across resistor 2, the second one in here. And this one is at 100 ohms. Oh, so this is our really small, this is by far the smallest resistor in the circuit. So let's see what happens. Start. Okay, well, this is kind of weird. We get a negative number here, right? So I did that on purpose, like I said I was going to do. That's just because the positive and the negative leads are just switched from what they ought to be. All right, so that's no problem. Current is it's designed to measure the voltage drop with current flowing in the positive side and out the negative side. All right, and we just flip-flop them. So let's switch that real quick. Let's delete that. Delete that. Let's have the positive coming from here. I'll just make it go like that. And the negative going to here. All right, and that should make it so we no longer have a negative number there. There we go. All right, so that's that looks good. That looks realistic. It's a very small voltage drop, but that makes sense because this is by far the smallest resistor in this circuit, and you'll get practice with this in lab 2 and the next couple of labs. All right, so that is our voltage drop, and we could do that same thing with any of these resistors in series, or even if they were in parallel. Now let's measure current. All right, and I started talking about this last time in the first session, but current is a through variable. We need the current to go through this multimeter right here, and we need it to be set for amperage. So what we need to do is actually break the circuit and then have one side of that break go to the multimeter set to measure current, and then the output of that multimeter set to current go back to the circuit. So what I'm going to do is delete this wire, and then I'm going to have the current from the positive side. I'm going to have that go to the positive terminal here. And I'm going to have the negative side of the multimeter go to the circuit. So all I did was I broke the circuit between here and here. That wire that I had between here and here, I just deleted that, got rid of it. And now instead of the current going directly from here to here, I'm going to make it go through the current meter, the multimeter set to measure current. All right? Let me pretty this up a little bit. All right, and let's make that one black and this one red. Okay. All right, so I think everything looks good. Let's trace the circuit real quick. Positive side of the voltage source, so the current comes out here through the red wire, through this strip to this meter that's measuring current, and then out this side to this part of the breadboard right here. It'll go through this resistor, then it'll go through this resistor, and we also have a multimeter measuring voltage drop across this resistor from here to here. And our current is going to go through this wire to this resistor, and then through this wire to the negative strip of the breadboard, and then back to the power supply. So this looks good. This should work. All right. Yep, that looks pretty good. So we've got 1.8 milliamps. That's not very much, but that's because we have a really large value of resistance. So our current is very small. So that's the amount of current going through our circuit. And we've got 180 millivolts drop across resistor 2. And we could do the same thing. We could measure the voltage drop across resistor 1, which would be different. Or we could measure the voltage drop across resistor 3, which would also be a different voltage drop. All right, I'm going to do one more thing. I don't want to belabor the point, but I want to make sure that everyone's clear, especially on how to measure this current, because sometimes this is confusing to students. So let me do one more thing, just to show you another example of how you can do this. So what I said was we need to break the circuit somewhere where we want to measure current. So I'm going to do the same basic thing, but I'm going to do it in a different location. So the original circuit that I had was from here to here, right? So my circuit was out the positive side, through this wire, through resistor 1, through resistor 2, through this wire, through resistor 3, back to negative, right? That was my original circuit. And this is a series circuit, so I only have one loop, essentially. So for a circuit like this in series, I can break the circuit anywhere I want to, and I can measure the current flow through that circuit. All right, so let me do it a slightly different way, because for this series circuit, I can break the circuit wherever I want to. So let's do it somewhere else. Let's break the circuit right here. Let me delete this wire. And what I'm going to do is have the current meter come from here. So I'm going to go from here to the positive side. I'm going to make it look a little better. And then I'm going to have the negative side of the multimeter measuring current go to this side. So this is just replacing that little jumper wire that I had right here. Okay, so let's make this look a little bit prettier. Let's make this come down. Let's make it go down like this. And this is going to go, yeah, that looks nice. Like that. All right. So now the current path is going to be through the positive side, from the positive side over to this wire, through this resistor, and then it has no choice but to go through this wire, measuring the current, and then out through this wire, where it will go through the third resistor, then through this wire, and back to the negative side. All right. So this is, I should get the exact same thing. You know, assuming that there might be a slight rounding error, but it really should be the exact same amount of current, because this is a series circuit. It should get the exact same thing. All right, so last time we got 180 milliamps. I think that was about right. So we should get the exact same thing this time. So let's do it. Oh, I think that, did we get one? Hopefully it was 1.8 milliamps. Hopefully it wasn't 108 milliamps. I'll go back and check and make sure after I get through with this video, but I think that should be the exact same thing that we got earlier. All right, so yeah, I think that's about it. You know what? Let me go ahead and show one more thing, and that is for a parallel circuit. Let's say you want to measure the current going through one particular branch of a parallel circuit. All right, so let's set that up. Let's say we want to make each of these resistors in parallel, and I want to measure the current going through each branch of the parallel circuit. All right, let's do that. Now, I'm going to have to rearrange all this stuff. So let's see, there's lots of different ways to do this. You could do this in lots of different ways. But let's say I'm going to rearrange these like this. And I'm going to have the positive side. I'm going to have the positive side. Yeah, here's how I'm going to arrange it. All right, I'm going to put 3 multimeters down here. Each of them are going to be set to current. I need one more. So I'm going to set this up so that this one is going to measure the current through this resistor. And these resistors are all going to be in parallel. This one's going to measure the current through this resistor. And this one's going to measure the current through this resistor. Okay? I just need to connect these wires to make that happen. All right, so I'm going to make for all 3 of these, the positive side is going to be the left side. So let me go ahead and make a wire from here to the positive strip, and from here to the positive strip, and from here to the positive strip. All right, and now what I could do to make a circuit, I could just connect here to the negative side, and here to the negative side, and here to the negative side. Then I would have 3 resistors in parallel, but I want to measure the amount of current going through them. So I need to make the circuit go from here to the positive side of this multimeter, and then I'm going to have the negative side of this multimeter go to the negative side of the breadboard right there. So that's what I want to do. I'll make this look pretty in a second, but I want to do that for all 3 of them. Positive side of this one. Actually, it's the negative side of the resistor, but it's going to the positive side of the multimeter. And this is going to go to here. And then for resistor 3, this one is going to go to the positive side, and the negative side goes to the negative strip. Okay. All right, now I just need to make it look a little bit prettier because this is a mess. All right. All right, how am I going to organize? Notice I can move these. Even after I connect wires to them, I can still move them. All right, so to make this look a little bit better, let me go like this. All right, that's fine. Okay, and then I gotta work with this one. So let's make. I'd like it to go around the multimeter and not through it, so I can see what's going on. So just take your time with this and make it clear what's going on, so I can see what's going on. Okay, I can't tell what's going on if the wires are going behind the multimeter. So let's make this go around. That's fine. Okay, I can see what's going on there. All right. Okay, I can make this go vertical. Okay. All right, so that's that should take care of number 1 and number 2, and then this one over here. Let's make this one a little bit prettier. So let's do this. Actually, we can just go like this. That's fine. And then this one, let's go around on the right side. Okay, there we go. That's fine. All right, now it's clear. I can make it even more clear by changing this color. Let's make the ones for R2, let's make these orange. The ones for R3, let's make these blue. And the ones for R1, we'll leave those green. That's fine. Okay, so now I've got 3 resistors in parallel, and I've got 3 multimeters hooked up to measure the current for each one. Okay, you might have to do something kind of like this in lab 2. So now trace the circuit. So we have from the positive side of the power supply, and now it could choose, the current could choose, kind of if we anthropomorphize the current, it could choose to go through this path, through that wire and through this resistor, and then through this multimeter measuring current, and then through this wire back to the negative side. It could do that, or it could go through this wire and then through this resistor and then through this wire to this multimeter measuring current, and then out the negative side and back to the negative side of this strip and back to the negative side of the power supply. Or lastly, it could go through this wire and then through this third resistor and then through this path to this multimeter measuring current, through this wire and back to the negative side of the power supply, right? So they're in parallel. I have 3 distinct routes that the current could take, and some current will take each route. So after setting that all up, make sure everything is set like it needs to be, and this looks like it should work. So let's get her going. There we go. All right, so you notice that they all have different current values. There's a different amount of current going through each branch of the parallel circuit, which makes sense because some branches have higher resistance than other branches. You would expect that the higher the resistance in a branch, the lower the amount of current. The lower the resistance in a branch, the higher the amount of current. So it looks like this one has the most current, this one has the least current going through it. So I can look at this and tell you that this one is the smallest of the resistors, and this one is the largest of the resistors. So if I click on this, can I do this while it's running? Yeah, I can. This one is the smallest. This is the 100 ohm. This one, I guarantee, is going to be the largest one, which was, what, 10 kilo ohms? Yeah, 10 kilo ohms. And this one has an intermediate current value, so it has the intermediate resistance value, 1 kilo ohm. All right, is there anything else I need to show you? I'm getting you all set up, not just for lab 1, but this is for lab 2 and subsequent labs as well. Okay, couple more things that I can show you. We're not going to use this, but if you ever want to use this function for something else, you could get a components list. So this actually tells you everything that you would need in real life to build this circuit. That you can do that by going to the component list up here in the upper right part of the screen. Oh, one last thing I was going to show you. I have on my list to show you. I'm not going to make you do this, but it's good practice to annotate your circuit. So we could, let's say, put a little sticky note right there and call this resistor 1, for example. And I can probably copy and paste this. Copy, paste, yeah. And let's put that right here and change it to, there we go, resistor 2, and then copy and paste right there, and we'll call this resistor 3. All right, that'd be a good practice. I'm not going to make you do that, but some of these get a little bit complicated, so it's a nice thing to be able to do. You don't have to leave it like that. You can click the minimize, and then they get smaller. And in fact, you can hide them by going to this button up here in the upper left. There we go. So now you can annotate it, and you can hide the annotations if you want to. There's an undo feature, so if you really screw something up, you can always do undo up here, and you can redo as well. So that's kind of handy to have. And I think that's about it. I don't think there's anything else I want to show you at this point. So make sure that when you're done, make sure you the easiest way is just to click print screen on your keyboard. That's fine. Or you can use the snip application in Windows. I use that all the time. And make sure you get the file name up here. I want to see your last name and lab X, whatever lab number it is. All right, I know that was a little bit more than you probably needed for right now, but that should get you all set up. And if you play around with this for probably even 15 minutes, I think you'll be maybe not experts, but certainly quite competent at TinkerCAD. All right, so there we go. That was a little brief introduction to TinkerCAD, and that is most of the functionality that we're going to use for the first third of this class. Hope that was helpful, and I'll see you in the next video.